Hello and welcome back. Today we are going to be talking about sample variance. So it's going to be very similar to population variance. If you had not watched that video already, I would recommend starting with that one. But sample variance pretty much asks the question. So population variance is we're taking data based on the entire population set. Sample variance says, let's take information based on a sample of that population, but not the entire population itself. And we should draw similar conclusions. Okay, so what do we have here? Suppose you survey 5 students from a school of 2,000 students. With those 5 students perfectly represent the entire school. Because a sample is only part of a population, we must slightly adjust our calculation to better estimate the true population variance. Okay. Some key vocabulary: population, the entire group of interest; sample, a subset of the population; sample mean. So now we have this symbol here. It's called X bar. X bar, pronounced as such, simply X with a line on top of it. It means the same thing as mu from the previous video. It's the average or mean of a sample. We just use X bar when we're talking about samples, as opposed to mu when we were talking about the whole population. They do mean the same thing, and if you mix them up and if you use one symbol over the other for your equations, it's not the end of the world. Sample variance. So the symbol here, so let's read the definition first. An estimate of the population variance using sample data. So for population variance, we used this symbol here. We use that symbol. For sample variance, we just use the letter S squared. You'll see here, this is the cursive letter S. For a lot of mathematics, sometimes letters and numbers can look similar. Like S looks pretty similar to 5. My handwriting is not always the best. Sometimes my S's look too close to 5s. So sometimes you'll see me use cursive versions of letters so that it's obvious that it's not the number. So this is just a script S. Okay. All right. And our last vocab word, Bessel's correction. Dividing by n-1 instead of n. In our population variance, we divide the whole thing by n. In sample variance, we will divide by n-1 instead. Why do we divide by n-1? When we calculate the variance from a sample, using n tends to underestimate the true population variance. Dividing by n-1 compensates for this and produces a better estimate. This adjustment is called Bessel's correction, probably named after the mathematician blah 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 Bessel who came up with it. Okay, and here's our formula. So you can see it's almost exactly the same as population variance. Population variance 1 looks like this. Oops, let's fix that. There we go. That's our equation for population variance. The only differences are, the main difference is n-1 instead of n. And remember, X bar represents the same thing as mu, and we just use the S for sample variance as opposed to the symbol for population variance. Oops. There we go. Okay, and I have all that listed here. S squared is our sample variance. This Greek letter, again, I believe is capital epsilon. Don't quote me on that, but that's what I think it is. Is summation of, we're going to add a bunch of stuff here. X sub I means each sample value. X bar is our sample mean. And N is our sample size. Okay. Here we have an example. Same exact data set as the previous example. Now, here we are given the elements 2, 4, 6, 8, and 10. This is assuming this is drawn from a much bigger data set. We're just taking a sample of a larger data set, but we don't need to focus on those things if they're not included in our calculations. But again, the data given for using this formula is under the assumption it is pulled from a larger data set. Okay, so just like before, I list how each observation corresponds to each X value. X sub 1 equals 2, X sub 2 equals 4, X sub 3 equals 6, X sub 4 equals 8, and X sub 5 equals 10. And these are all of our X sub i's from the equation. All right. And N is 5 because we have 1, 2, 3, 4, 5 observations. All right. Step 1, calculate the sample mean. done this a million times. Our sample mean X bar is the sum of all of our observations divided by the number of observations, which is 2 plus 4 plus 6 plus 8 plus 10 divided by 5, which is 30 divided by 5. Our X bar, our mean, is 6. Okay, and that's this part of the equation right over here. Step 2, find each deviation. We take each observation and subtract the mean from it, subtract X bar from it. So here we have each observation minus minus the only mean we have, and we get -4, -2, 0, 2, and 4, and that's the inside of the parentheses portion of our equation here. Step 3, square each deviation. Take each value found from step 2 and square it. -4 squared, 16, -2 squared, 4, 0 squared, 0, 2 squared, 4, 4 squared, 16, and highlighted over here is the part of the equation we just focused on. Step 4, add the square deviations, the summation part. Again, just like last video. This time I'll make it a little bit neater. X sub 1 minus X bar squared. That's the 16. X sub 2 minus X bar squared. That's the 4. X sub 3 minus X bar squared. That's the 0. X sub 4 minus X bar squared. That's the 4, and X sub 5 minus X bar squared. That's the 16. Again, everything we just calculated from step 3, we just added up now. And when we add it up, 16 plus 4 plus 0 plus 4 plus 16, 40. And lastly, divide by n minus 1. Okay, so here's our equation written out. Our numerator is 40 from step 4, and then our denominator, our n is 5 for our 5 observations, minus 1 gives us 4. 40 divided by 4 is 10. Therefore, the sample variance is 10 square units. That's it. All there is to it. Again, not as tricky or complicated as it might look at first glance. Comparing population and sample variance. Okay, so using the same data set from the last video with the population variance, we get 8, and the sample variance with the same data set gives us 10. Notice that the sample variance is slightly higher because of the n-1 adjustment. And this is to account for the fact we're taking it from a sample. We don't know the rest of the data. Real world applications, opinion polls, clinical trials, quality control using sample products, scientific research and educational testing. Common mistakes, dividing by n instead of n-1. Remember, we use n for, let's do that the other way. N is for population. N-1 is for sample. And we didn't get to standard deviation yet, but spoilers, there is going to be population versus sample standard deviation, and spoilers, it's going to be the same thing. The population divided by n, sample n-1. So just try to keep that in mind. All right, other common mistakes: forgetting to square each deviation, mixing up sample mean X bar and population mean mu. That one's not the end of the world. I think most people in research or academia will let that slide. Confusing variance with standard deviation. These get mixed up all the time. Be careful with that. And like I said, this will be covered shortly. And that last mistake, forgetting that variance is measured in square units. Okay. All right, so let's finish up with a practice problem. You should notice these are the same questions from the last video. Find the sample variance of 5555, find the sample variance of 357911, and lastly, why do we divide by n-1 instead of n? Feel free to pause the video here and take a look. All right, hopefully you worked on these. Let's take a look at the answers. So 1, I didn't even do the work. We went over this in the last video. If you have questions on this, I would recommend checking that video out. But our sample variance is 0. We don't even need to do any work. We know it's 0 because these are all the same elements. 5, 5, 5, 5. The average of 4 5s is 5. When we subtract each one, we get 0. The whole thing is just going to turn to 0. Easy peasy. Step 2, I have the work listed out because that's a little bit different. X sub 1 is 3, X sub 2 is 5, X sub 3 is 7, X sub 4 is 9, X sub 5 is 11, N equals 5 because we have 1, 2, 3, 4, 5 observations. And the mean of our 5 observations, we add them all up, divide by 5, we get 7, which is also our median. All right. Then we take each observation, subtract our found mean from it, and square that number. We should get, so this is 3 minus 7 squared, which is negative 4, 16. 5 minus 7 squared, negative 2 squared, which is 4. 7 minus 7, 0 squared equals 0. 9 minus 7 squared is 2 squared is 4. And then 11 minus 7 squared is 4 squared is 16. Okay. Here's the equation written out. We found this whole top bar. We add each of these up because that's what the summation tells us to do. 16 plus 4 plus 0 plus 4 plus 16 over 5 minus 1. Don't forget the minus 1 gives us 40 over 4, which simplifies to 10. Our sample variance is 10. And lastly, we divide by n minus 1 instead of n to obtain better estimates of the population variance from a sample. We divide by n minus 1 again because it's a sample. Cool. And that is everything I have for you on sample variance. Thank you for tuning in. As always, a link to the notes will be in the description, and I will see you next time. Take care.